Welcome everyone to an Out2Lunch webinar. These webinars are brought to you by the Earth Science Information Partners Education Committee, and they're held Wednesdays at noon Central Time. We're happy that you can make it. Chris, if you go to the next slide. These are 10-minute demonstrations of Earth Science data, tools, and resources with 5 minutes afterwards for Q&A. And you can visit our past presentations on our wiki page or on our Out2Lunch YouTube playlist. And with that, I will hand it over to Chris, who will introduce himself and share a little bit about a flooding module today.
Yes, hello everyone. My name is Chris Lohr and I am a research assistant at the Concord Consortium. I'm very excited to be here today to round out a set of talks about an NSF-funded project called GeoHazard. Back in early or late December of 2020, I think I had almost back-to-back presentations of our wildfire and our hurricane modules. And finally, we released our flood module to the public. So that's what I'm going to present today. And thank you to Carla and ESET for hosting us these 3 times and inviting us to talk. So I'm going to talk about a computational model for the curriculum we created about flood occurrence, hazards and risk. And this work was done under the direction of our principal investigator, Amy Pallant, and our partners at Penn State and National Geographic and Turk. So in the GeoHazard project, the goal of this project is to have students explore natural hazards and extreme events, the predictability and physical impact of these events, and the risk to human lives. In this flood module, students investigate and observe the environmental factors that cause and propagate a hazard, and also reason about the impacts and risks that hazards bring to communities. As I mentioned before, we created 3 natural hazards modules. Today, I'm going to go over the flood one. And like most geoscience topics, teaching about natural hazards and Earth systems poses interesting challenges in the classroom. Natural hazards are the result of the interactions of many factors in a complex system, so scientists rely on computational modeling as a way to explore these systems. Computational models of natural hazards provide opportunities for scientists and students to gain understanding of underlying geological forces and make forecasts on the locations and likelihoods of future events. I'd like to point out that this work incorporates several NGSS practices, such as developing and using models, planning and carrying out investigations, constructing explanations, and engaging in argument from evidence. And it also addresses one of the disciplinary core ideas of ESSS 3.b, natural hazards, where under this core idea, NGSS wants students to understand the system of geological forces that can help forecast the locations and likelihoods of future events and how they can take steps to reduce their impact. So the main reason we decided to focus on floods as a natural hazard is because they've been a huge problem for the US in the past decade, and it doesn't really appear that they're going to become any less of a hazard in coming years. This quote from the US National Climate Assessment in 2018 is pretty telling. It says that billion-dollar floods in the Midwest have occurred 3 times in the last quarter century. Climate projections suggest an increased risk of inland flooding, and average annual damages from heightened flooding risk in the Midwest are projected to be in excess of $500 million by 2050. So it's a big problem, and another study found that about 41 million people in the United States are at risk of severe flooding right now. So it's something we have to deal with every year, and it's important for us to teach students about floods. And, for example, here's a risk map produced by NOAA for the US flood outlook this spring. It's showing parts of the US with at least a 50% chance of minor, major, or severe flooding in March through May 2022. I know that in the past few days and today that there's a huge winter storm up in this Midwest region here, which is likely to drop, feet of rain and snow and probably cause flooding when the snow melts and the rivers swell. So unfortunately, this prediction may come out to be true. But this map provides some insight about where the flooding may occur, and it prompts a couple questions about why it occurs in this location and how. So for example, some of these questions are, why are these areas most at risk of flooding? Why are some areas forecasted to have more severe floods? Why is there only a risk of flooding in the Midwest and not really in the Northeast or any part of the West? And does climate change affect the occurrence of floods? So to help students, try to answer these questions and build knowledge around these flooding hazards and risks, we want them to explore and experiment with environmental factors that contribute to flooding. And so we've created this model called the Flood Explorer to help them investigate these factors. And before I get into the model, it's important that we define the risk so we can break it down into comprehensible and analyzable bits for students. So in the flood module, we define risk as the likelihood of flood hazards reaching a place and the severity of those impacts that those hazards could bring to the people living in that community. So the likelihood could be a percent or probability, and the damages could be measured in dollars or buildings lost or crops destroyed, something like that. But risk is not only like the calculation of the probability and the dollars lost, right? There's several other factors that may affect someone's assessment of risk in a situation. There's the person's scientific knowledge about the natural phenomenon, the knowledge of the community that's at risk, like what is likely to be lost or damaged, and the personal values and experience held by students, right? For example, in the many hurricanes in the Gulf or in the East Coast, there's frequently that news clip of someone saying that despite the predicted risk of this Category 4 hurricane coming, they're not going to leave their homes because they care about them and they don't want to leave it in the storm, right? So their personal values factor heavily into their perception of risk and the actions they take based on that risk perception. So it can't just be this calculation of these two factors. You have to consider the personal and community-wide factors as well. So here is the Flood Explorer model, which helps students experiment with factors that affect flooding. We made this because natural hazards are complex real-world natural systems, and it's difficult to study them as they occur in nature, right? We need simulations in order to understand flooding and simulate different kinds of floods. So the simulation has a map on the right and several types of graphs on the left. On the bottom, students can control environmental factors that influence flooding, such as the amount of precipitation, the duration, the starting water level, and the permeability of the land in the map. They'll also be able to adjust or experiment with societal factors, such as increasing population, urbanization, and mitigation techniques using levees here. So all of these factors that they can play with play a role in risk and impacts to communities that are vulnerable to river flooding, such as our fictional Silver City here. And I'll show you more how the simulation works in a second, but I want to go over the curriculum real quick. So we embedded the Flood Explorer model into a 5-activity curriculum module where each activity is designed to take around 45 minutes of class time. It's all online, free to use, and is now, as of last month, completely available to the public. I'll give you the link at the end of the talk to go visit the page. It comes with, the whole module comes with teacher materials like a guide on teaching with online materials, NGSS alignment, dealing with socio-scientific issues in the classroom, and a full teacher edition of the module with teacher tips, exemplar answers, discussion questions, and digging deeper activities. So now I'm going to show you a couple pages of the modules that have the simulation. So here's a page in activity 4 where you can see the simulation embedded in the page. I'm just going to run an experiment here by adjusting the amount of rain. I'll make the storm duration long, and I'll set the starting water level to high. I'll press start, and several things kind of happen, right? We see this counter up here start to go, and we can see the cloud or the sun based on what the weather is. We can see the river start to swell as the storm, drops a ton of rain on the area. We can see this flooded area over time graph respond to the conditions in the model. So as the area flooded, this graph went up. We saw that at maximum flood extent, 1,800 acres were flooded, and it quickly dropped back down to 0. I can move this slider to see different conditions at different times. And I'm going to run it again. And this time we will watch the gauges. We have 3 stream gauges that allow us to see kind of a cross-sectional view of the river and the banks of the river at those points. And so we can see when we adjust the starting water level, for example, that the water table level changes, right? And this affects the outcome of flooding. If I use the same conditions and we run a low, but we started with a low starting water level, we can see the river stage remain low until the rain starts to really start falling after a couple days. And it begins to increase. And we'll see once the river stage crosses this orange line, that indicates that it is above the banks of the river and we see some flooding. And it will drop back down to where it was. But we can see there was flooding, but if we go to the graph, we can see that there was not nearly as much flooding as when the starting water level was high, just one factor that influences the flooding. We also have different map types. So the default is a street map where we can show places and points of interest in the town. We have a topographic map, which may help describe why certain areas flood compared to others, right? The water will follow the lowest part of the terrain. And we have a permeability map. Permeability is the measure of how well the ground will absorb water. So in a low permeability area, such as the center of the city, we can expect water to not absorb well because it's covered in pavement with parking lots and sidewalks and roads. But in the rural areas, there's a high permeability, meaning water will easily infiltrate into the ground, and it may lessen the impact of flooding because it can absorb more water than the Silver City downtown. To explore this idea more of permeability, I've been idle for too long. We created several different map types. So we kind of start with the modern day Silver City, and later in the module we go back in time to when Silver City was just silver tin and it was kind of first growing. It was just kind of maybe a frontier town. We can see much less development, right? So because of this, if we go to the map types, we're able to see that the permeability is all green. It's all high permeability, easily absorbs water from flooding. And if I run it with the same conditions that we had before, we would expect to see maybe less flooding with the same conditions than we did in the more developed, urbanized, more populated Silver City of the present day. And just barely, we went just almost to the same place, but we can see it maybe dropped quicker because the water is absorbed faster in the ground than it is in Silver City. Finally, in the last part of in the last activity module, we have yet another map type that is Silver City 100 years in the future, right? I think this is it. Yeah, so if we go to the map type of permeability, we can see that there's much more low permeable areas than there were even in the modern day Silver City. And if we set to the same conditions, we would expect to see more flooding. Now, there is another factor that we increased in this future amount to kind of mimic the changes that a warming climate will have on flood impacts and risk. And this is that we've added extreme amount of rain, right? Because climate change, while it may not increase the number of rainstorms, it definitely increases the intensity of each rainstorm. Each rainstorm will drop more water in the same or shorter amount of time than it does right now. And we can see that while it also had way more acres flooded than the previous two maps, it also is taking much, much longer for the water to go away because it's kind of puddled in these very impermeable areas, and has extreme trouble permeating through the pavement. Finally, we can add levees if we want. So if I click this levee button and I want to protect, let's say, the hospital, right? I can click along the edge of the river. I have 10 levees to place, but I'm happy with my current setup right here. And I'll click start. And you can see in the cross section that this concrete levee showed up when I placed it there. And hopefully it blocks the water from hitting this part of the city. And I'd say the hospital was pretty much saved by our efforts, so that's good. But in the curriculum, we have students, pick these points of interest that they think are most valuable saving. And we get a really good picture of, what they value. Some students pick Ben Fields to protect because although there's no one living there, they love playing ball, right? So they don't want their fields to flood so they can't play baseball or soccer or whatever. A lot of kids do pick the hospital or the elementary school for really good reasons. And this is the kind of reason we want to get at with these hazards and risks, is that they take into account all these different factors and their personal values and combine them into assessment of risk that they can use in these simulations. So if you have any questions, I'm happy to answer them. Here are the links that you can go to. There's a GeoHazard flood page. The Flood Explorer can be accessed on its own. And if you are interested in viewing any of our Concord Consortium or science materials, you can go to this link here. I think Carla will put them in the chat.
I put them in the chat. And if you, Chris, can you see the chat?
I can.
Can you click on that last link, which is a Google Doc form that I sent?
Yes.
So Kathy and Meg, this is of particular importance to you. We have ESIP implementation grants that we give out throughout the school year. If you implement one of our resources, and those resources can be resources from our summer workshop, which is posted online, or from any one of these Out2Lunches. So for example, if you implement the flood module with your students and submit to us by May 27th, you could receive a $500 implementation grant. Now there's competition because lots of teachers apply for these, but it's worth applying for. It's a very short application. And if you scroll down just a little bit there, Chris, there's one that says the name of the ESIP resource you used, and all you'll need to do is to go down and choose Out2Lunch. There you go. It's down there. Yep. And when you choose Out2Lunch, then you'll just describe, I implemented the flooding Out2Lunch. And there's some questions there asking you about what you did with kids. But you're certainly welcome to go back and implement the wildfire one if you want to, or the hurricanes. Chris has given, all those talks are posted. So any one of those Out2Lunches, these other ones come from our summer workshop, and they're like, some of them are hour-long presentations. And now open it up for questions for Chris.
Cool. Well, if you have any questions, feel free to reach out and email me.
Kathy has put something in the chat. Would this be appropriate for 6th grade?
Yes, yes. We do try to aim for middle school grades here. So 6th grade would be kind of right in the wheelhouse of what we aim for.
Is the Flood Explorer GeoHazards activities, is that integrated with Concord Consortium, like for example, the plate tectonics modules are?
Yes, yeah, absolutely. The plate tectonics is run by the same people. We all work on that one as well.
Okay, great, because that was really fantastically integrated. I used it for the first time this year and it was fantastic.
Oh, great. You ran the geode module?
Portions of it too. That's what I liked about it, is pick and choose what I wanted to use.
Yeah.
And then I had them using just the Seismic Explorer for some things too.
Nice. Yeah. That's a great tool. I use the Seismic Explorer just to check on earthquakes, a couple times a week. So yeah, it's awesome.
Yeah, yeah, it's nice. And as far as the grant goes, if I were to implement this flood hazards between now and June, before the thing is due.
May 27th, yeah.
Okay.
It sounds
That's my-
like though, Meg, I'll just point out that I'm pretty sure Amy presented in one of our previous Out to Lunches on
Oh,
the geode. So you might be able to write that one up.
oh, wow.
Yeah, so you just need to go to our, you'll get these, I'll post these links, but I can also send you an email with the link that goes directly to the YouTube channel.
I
And
just
then
lost you.
Oh yeah,
Oh.
Carla, we lost you for a second.
Sorry, we have it all in one space that I can send you the link to after I post Chris's.
Okay, sounds great.
And
Yeah.
then you can see if you've actually implemented something, because you may have.
Oh, right. There's the student record there.
Mhm.
Oh,
Yeah, geode plate tectonics right there. So we did it. Amy did that. Might have been a year ago, but our intent, these resources don't expire after one 15-minute showing. That geode module is a very solid module, and it's going to be around for a long time. So we encourage you to go back and look at all of our past stuff and implement any of those.
yeah. I tell as many people as possible.
Awesome. Thank you.
You're welcome. Thank you.
And we do have another Out to Lunch next week, which is a new tool from Trinity Foreman. And I just lost where I had put that. Sorry. But we're back in the swing of things. We took a few weeks off for spring break in March and April because people just weren't around. So, but we're now for several weeks in a row, we'll be continuing to have these Out to Lunches. So do spread the word, please.
Great. Thank you very much, Carla.
Thank you so much, Chris. Appreciate it. And hope to see folks next Wednesday.